Here's a set of quick tips for helping you debug those pesky situations where something is going wrong with your collisions, but you can't quite figure out what. I'll start with the obvious one that most people know, which is turning on the collision boundary visualization, and then move on to some lesser known helpful techniques, including how to debug raycasting. But to do that, we need an example game to debug. So let's create a quick one with a movable character, a floor to fall onto, and a wall to run into. We'll start by using a character body 2D node, adding a sprite 2D with the default Godot icon, and adding a collision shape that roughly matches the sprite. If you're already familiar with creating basic platform-based video games and just want the debugging tips, skip forward to the 2.5-minute mark in this video where the real debugging begins. We'll move our new player over to the top center of the view screen, where he can fall directly to our floor, which we'll need to create next. We'll create a static body 2D node to use as the floor. We'll use the same sprite icon, but expand it to fully cover the shape of the floor, along with another rectangular collision shape. This is super ugly, but it works for this cheesy game demo. The best way to get better at object creation in Godot is to just do it over and over and over. Finally, we'll add a similar wall on the right using the same sprite icon and again yet another collision shape. When you're trying new things, I highly recommend creating a very basic game like this instead of trying to learn something new in an already existing and likely complex project. Having a separate clean space to work in will really help you understand the new skill you're trying to pick up. Next, we'll save the scene as main and then rename the top node to main as well to match. To finish this quick game off, we have to go back to our character body 2D and add a script so that it can run, jump, and, most importantly, fall to the floor. The default template for the character body 2D is already perfect, so we'll make use of it. Now let's save everything and run it. Sure enough, we can move, jump, and of course, fall. Let's move on to the visual debugging assistance techniques. To begin with, let's turn on the Visible Collision Shapes option under the Debug menu. This makes our collision boxes visible when playtesting the game, just like they are in the editor. Most people are aware of this option and it's highly helpful, although when you get too many objects on the screen it can be a bit overwhelming at times. So when a game is too overwhelming, remember one thing. This is your game! You can add and remove new graphical elements anytime you like in order to help you create your game and to debug it. As an example, let's add a polygon 2D object that is about the same size as our collision shape. We'll change the color to green and set the alpha to 64. Now when you playtest the game, you have just the collision boxes you wanted to study without all the other ones cluttering up the screen and confusing you. You can even leave them as part of the game and toggle their visibility or simply remove them when you're done with them. Note that if you want it to be a halo effect, you can simply move it above the sprite object. Okay, let's turn to the task of debugging raycasting. If you're not familiar with raycasting, this won't be a tutorial on it, but essentially raycasting allows you to use an imaginary path from one point on the screen to another and see if it hits anything along that path. The problem is that it's really hard to see what's going on when you're using raycasting. Are your rays long enough? Are they aiming in the right direction? Are they starting in the right place? These are all problems we want to solve today. The good news is that I've made this easy for you with the plugin tool. So grab raycast_debugger.gd file from the GitHub repository in the link in the video and drag it to your project to install it. Then, in the code for our player character, we can define a variable to store an instance of it and create it in our ready function. Note that this plugin contains only the basic raycast option, so you may want to modify its code to suit your specific needs. Note that we do need to add it as a child of ourselves to make sure that its code will eventually get called appropriately, so use the add child function to do just that. To actually perform the raycasting, we can use the created instance and its intersect_ray function to perform a raycasting for testing collisions. For this demo, let's create a ray from our character to 200 pixels below it. The third argument is the list of objects to ignore, which we'll frequently want to be ourselves, so we'll pass in an array containing our self object. If the cast returns a result, we'll simply print hit the ground. Now, if we start the game, we'll note that as we get near the ground, we'll eventually see hit the ground appear in the output. But how long is that ray? Is it too short or is it too long? When does it actually first hit the ground? Let's go back to our code and set the enabled debugging flag of our raycaster instance and run it again. Voila! Now we have a visual green line that shows the actual ray. And note that when we actually collide with something, the green line is overlaid with a thinner red line so that you can see exactly where the collision happens. This should make it far easier to figure out exactly where we have raycasting bugs. As one final example, let's create a horizontal ray as well for testing when we hit the wall. We'll use a similar approach in the code, and then when we run our code again, we'll see that there are two lines emanating from the player that visually show every ray and where they collide with other objects. Now that we've seen how this works, let's see a real game with raycast debugging enabled. This is my game Frustration Factory, which caused me endless headaches in trying to get collisions working properly. I'll save those details for another video. But note how all the moving pieces have raycasts shooting out of them, and note that when the pieces fall into a hopper and are later released, all of a sudden the rays don't align with the pieces any longer. Bug found! Now to fix it, but you don't need to see that. Do note that in this bug there are both a translational offset and a rotational component to the rays. This would be very hard to spot by just looking at the numbers. One final tip, you can bind a keystroke to toggle debugging on and off. Just make sure that it's disabled when creating a release. That's it. I'd say happy debugging, but nobody really enjoys debugging. Okay, except for this one friend of mine.